Somewhere in the world tonight, there is a person who will not sleep. Not because they are working late, not because they are anxious or in pain or staring at a ceiling waiting for morning. They will not sleep because they no longer can. The part of their brain that produces sleep is being destroyed, one cell at a time, and nothing will stop it. They have a disease with no treatment and no survivors. And here is the strange part. When doctors first tried to explain why that disease is fatal, they could not. Because science still cannot fully explain why you need sleep at all. We only know what happens when you do not get it. So this is what happens, hour by hour, all the way to the end, 24 hours awake. Nothing dramatic has happened yet. You feel irritable, foggy, a little slow. You would tell someone you are fine. You are not fine. After a full day without sleep, your cognitive performance is roughly equivalent to a blood alcohol level of 0.10. That is over the legal driving limit in every state in America. You are, functionally, drunk. And unlike being drunk, you have no idea that you are impaired. That is the first thing sleep loss takes from you, not your ability, but your ability to judge your ability. 36 hours. Now something genuinely strange begins. Your brain starts shutting itself down in pieces while you are still awake. They are called microsleeps. For anywhere from a fraction of a second to 30 seconds, part of your brain drops into sleep while your eyes stay open. You do not notice. Your brain quietly stitches the gap closed, so the missing time feels continuous. People have microslept mid-sentence, mid-step, mid-highway. Around here, the first hallucinations arrive, usually small, a shadow that moves, something at the edge of your vision that is not there. 48 hours. The hallucinations stop being small. They become complex, and they become convincing. Not shapes and flickers, but people, objects, events that your brain constructs and presents to you as real. Alongside them comes a strange emotional weather, anxiety, then euphoria, then a flat sense of detachment, as if you are watching yourself from slightly outside your own body. Your brain is now so desperate for sleep that it has begun dreaming while you are still standing up. 72 hours, 3 days. Now the hallucinations come with sound, voices, noises that no one else hears. Your hands shake. Your thinking fragments into pieces you cannot hold together long enough to finish a thought. And the microsleeps stop being brief. They get longer, and they get harder to fight, until it is no longer really a question of willpower. Your brain is not asking permission anymore. It is taking what it needs. In 1963, a 17-year-old named Randy Gardner decided to find out how far this goes. For a high school science fair, he stayed awake for 11 days, 264 hours. By the end, his speech had slowed and slurred. His short-term memory was failing. He was paranoid. At one point, he mistook a street sign for a person. At another, he became convinced he was a famous football player. He was monitored by a sleep researcher named William Dement, who would go on to help build the entire field of sleep medicine. Then Randy went to bed. He slept for 14 hours and 40 minutes. He woke up. And over the following weeks, he recovered completely, with no lasting damage, which leaves us with a problem. If a teenager can lose 11 days of sleep and walk away intact, then sleep loss by itself does not kill you. So what does? To answer that, you have to look at the people who cannot choose to sleep again. The disease is called Fatal Familial Insomnia. It is caused by a prion, a single protein folded into the wrong shape, which then persuades the proteins around it to misfold in the same way. A chain reaction with no breaks. It attacks one structure in particular, the thalamus, sitting deep in the center of the brain, which acts as the gateway between your senses and your consciousness, and which governs your descent into sleep. The prion kills the neurons there. And as it does not make sleep difficult. It removes the machinery that produces sleep at all. This is the distinction that matters. Randy Gardner was choosing to stay awake. These patients have lost the ability to do anything else. It is inherited, and it is extraordinarily rare. It has been documented in just over 100 families worldwide. It usually begins around the age of 50, and it follows a path. First, sleep becomes shallow and broken. Then comes panic, sweating, a racing heart, pupils shrinking to pinpoints. The body behaves as though it is under threat, permanently. Then, sleep stops. Not reduced, stopped. After that, weight loss, loss of coordination, dementia, the loss of speech, and finally a coma the patient does not wake from. From first symptom to death takes anywhere from 8 months to 6 years. Sedatives do not fix it. In many cases, they make it worse, pushing patients into confusion without ever delivering sleep. So we return to the question, why is that fatal? In 1989, a researcher named Alan Rechtschaffen ran the experiment that made the problem unavoidable. Rats kept from sleeping died in about 2 weeks, reliably, repeatably, and when they were examined afterward, there was no clear reason, no lesion, no failed organ, no anatomical cause of death. Along the way, the rats had developed skin lesions, lost body temperature, and lost weight while eating more than the healthy controls. Their bodies were burning through themselves, but nothing in them was obviously broken. They simply died. And for 30 years, that is where the answer stopped. Then, in 2020, a team at Harvard found it, and it was not where anyone was looking. They kept fruit flies awake. The flies began dying on day 10, and all of them were dead by day 20. Then, the researchers went looking for the damage. It was not in the brain, it was in the gut. Sleep-deprived flies were accumulating reactive oxygen species in their intestines, unstable molecules that tear apart DNA, proteins, and fats. The buildup began around day 7 and peaked, precisely, on day 10, the day they started dying. So the team tried something. They gave sleep-deprived flies antioxidants to mop up the damage. The flies stopped dying. They never slept again, and they lived a completely normal lifespan. Then, the researchers checked mice. Kept awake for 5 days, they accumulated the same reactive oxygen species in the same place. The gut. The thing that kills you when you do not sleep may not be your brain failing at all. It may be a slow chemical fire in your intestines that sleep is quietly putting out every night. Which brings us to what sleep actually is. For most of history, we assumed it was rest, the body idling to save energy. It is not. Sleep is maintenance, and it is active. During deep sleep, fluid is pushed through channels in your brain in a process called lymphatic clearance, washing out the waste your neurons generated while you were awake. Among the things it flushes are amyloid beta and tau, the 2 proteins that accumulate in the brains of people with Alzheimer's disease. That clearance runs faster when you sleep, and it is measurably impaired when you do not. Every night you are unconscious, your brain is being rinsed clean. You will spend about 1/3 of your life asleep. Around 26 years, unconscious, unaware, defenseless. It is easy to think of that as time lost. It is the opposite. It is the price of the other 2/3. It is the maintenance window that keeps a brain and a gut and a body running long enough to have a life at all. For the families who carry fatal familial insomnia, that window closes and does not open again. Researchers are now testing whether the disease can be caught before symptoms start in people who know it runs in their blood. For everyone else, the machinery still works. Tonight, it will run again. You will not remember any of it. That is rather the point.